Rules. A, solve the sign first. B, do the operation on the coefficients, do the operation on the radicand, and then simplify. You can only multiply or divide radicals if they have the same index. That makes sense? So you can only multiply a square root with a square root or a cube root with a cube root. Okay, so root 3 times root 5. You should already know how to do that. What is it? Root 15, right? This goes with the rules of simplification. Except for we were always going the opposite direction, right? We were always going the opposite way. So we were taking root 15 and we broke it down. So we're actually going to multiply. The last thing is we have to ask ourselves, can we simplify 15? Is there a perfect square that is a factor of 15? No. So we're done. Okay, so root 3 times negative root 8. So sign first is negative. What is root 3 times root 8? 3. Yeah, this is where it just is like basic times tables. Isn't it fun? Okay, so then we ask ourselves, can you simplify 24? Yeah? What would it be? What product would you use? 4 times 6, which equals negative 2 root 6. We're all good with that. Any questions? Yes. The whole thing is kind of a negative, so you just leave it out front. Yeah. We wouldn't bring it inside, right, because you can't square root a negative. So it really is like one of them is negative, one's positive. We just write it in front. You don't really know which one. Okay, so when we multiply like 5 root 2 times 7 root 3, we have coefficients. So we multiply coefficients with coefficients and radicals with radicals. So 5 times 7 gives you 35. This is where you need to know your times tables, especially as an AP class. Root 2 times root 3, root 6. And then can that be simplified? No. So easy, right? So fun. Easier than adding and subtracting. Maybe not. Okay, what's negative 4 times negative 5? Positive 20, good. And now what's root 6 times root 2? Root 12. Can you simplify root 12? Yeah, look, it's like Christmas colors. Festive, hey? Holiday colors, for being politically correct. Okay, so 20. What can you break up 12 into? 4 and 3. Good. What's the square root of 4? It's 2. And so you might go straight to the final answer, right? Which is what? We're always multiplying here. 40 root 3. The operation between each of these is always multiplication. Okay, try the 5. All by yourself. Don't wanna be, no? Yep. I miss my calling. Start you. Make this higher. There's gotta be a way. Okay, what'd you get? First step, 6 root 18. Then what did you break up 18 into? 9 and 2, which gives you 6 times 3 root 2, or 18 root 2. Can you check your work? Yes, that's what calculators are made for. Complicated problems, checking your work. So you sub in the original question, sub in your answer. Do you want me to show you? Yes? Okay, you have to do it too then. Don't hang me out to dry here. So type in 3 root 6 2 root 3. Get a decimal and type in your answer. 18 root 2. Should be the same decimal. Okay? So easy. Okay, so let's make it a little bit more interesting. We can apply our same concepts to distributive law. So what is distributive law? We covered it back in grade 9 and 10, right? Yeah? Oh, right. Sorry, 6. How would you do number 6? Yeah, you don't. Thank you. Good. Yeah. Why? Different index. And there's no coefficient, so I can't even bring the it's literally just leave it. Done. Yeah. Okay. So distributive law, if I want to bring the 2 inside the coefficient of 2, multiply what is outside the bracket by each term in the bracket. 2 times root 2, what does that equal? What is 2 times root 2? How would you write that? You would write that as 2 root 2. Because you only really combine coefficients with coefficients, radicals with radicals. Okay, so what is 2 times 1? Just 2. So 2 root 2 plus 2. Did that make sense? Sort of? Okay. You guys remember FOIL? Did you ever meet Binomial Man? He just needs a little hair. And there is Binomial Man. Give him glasses. Is that better? I don't know. Okay. So, with FOIL, right, first outside, inside, last, I'm going to multiply. I'm going to erase Binomial Man. Say goodbye. Bye, Binomial Man. Aww. Okay, so we're going to take root 2, and we want to distribute the root 2 into both terms in the second bracket. So those are that's the first F, right? Root 2 times root 2, what does that equal? Root 4. Now in the future, we're going to go straight to, when we go root 2 times root 2, what do you think we'll go straight to writing that as? Just 2, right? Because root x times root x is the same thing as root x squared, or x. So right now we'll write it as root 4, but in the future, if we have root 2 times root 2, that equals 2. Okay, root 2 times positive 1. Devinder. Root 2 times positive 1. 1 square root 2. You don't have to write the 1, but you can. 2 times root 2. Ben. 2 root 2. And 2 times positive 1 is just 2. Okay, and our last step is we simplify, then collect like terms. So root 4 is actually just 2 plus, how many root 2's do we have? Collecting like terms. You have a root 2 plus 2 root 2. How many root 2's do we have? 3, right? This is a 1 root 2. 1 plus 2. 3 root 2's. Plus 2. Or our final answer would be 4 plus 3 root 2. You having fun yet? It is. It's just like taking FOIL and radicals and boom. It's beautiful. Easy. Okay, so to expand, last little note there was to expand an expression means to remove the brackets and simplify. So let's expand and simplify. Whole bunch of practice. Okay, try a 1 and 2 by yourself. Then we'll go through them. Because it's just more distributive law. Try those two. So expand them and then simplify if needed. First, you should have had negative 10 root 3 minus 8 root 21. Can you simplify either of those? No. It's supposed to be 3. Okay. The second one, you should have, and you might have gone straight to this. 5 times 3 is 15. What's root 2 times root 2? You can either write it as root 4 or just times 2. Because square root 2 times square root 2 is 2. And if you get into the habit of that, it makes it go quicker. Yeah. Well, it's this. So when you're multiplying root 2 root 3 times the 5, these are all being multiplied together. It's the same thing as writing negative root 2 times root 3 times 5. So you're not using distributive law necessarily between them because there's no addition sign. And you could only really combine radicals of radicals and coefficients with coefficients. Okay. And then 5 root 2 times negative root 6, I get, this is the same thing. If you have to, write the coefficient of 1 in. So when you multiply your coefficients of 5 times negative 1, we get negative 5. Root 2 times root 6 is root 12. Okay, now we're not done. We want to simplify this. 15 times 2, you should have had 30 here. You might have had 15 times root 4, right? Root 4 is 2. Okay, now 12. Can you simplify 12? Yeah, we can break it into 4 times 3. So that would have been 5 times 2 root 3, or 30 minus 10 root 3. Okay. How is that? Okay. So it's like this kind of stuff. Usually students make mistakes with just simple errors, like mistake on a sign, right? Forgetting to simplify. So you have to be very careful with each step. So let's do 3 together. And what are we going to use to solve 3? FOIL. I heard it. Yeah, we're going to FOIL. So start with 3. 3 times 2 is 6. 3 times 4 root 5. What is that? 12 root 5. Good. Now the root 5 times 2. How would you write that? 2 root 5. It's like multiplying an x and a y, right? You just write it as xy. Root 5 times 4 root 5. So the coefficient of root 5 is just a 1. So first, what's the coefficient going to be? Plus 4, 1 times 4. And then, how can we write root 5 times root 5? Just 5, because it's root 25, which is just 5. So write 5 in brackets. Okay, so simplifying this, I have 6 plus, how many root 5s? 14 root 5s. We add the like terms, plus 20, or 26 plus 14 root 5. Any questions about that? Yeah. Because 14 has a root 5 to it. And so we can only add them together if they have the same radicand. And so technically the radicand of 6 would be like 6 root 1 if you put a radicand, right? You can't combine them unless, so they're not like terms, so to speak. Okay. All right. All right, root 7. Whose phone's on? Turn it off. Okay, root 7 times root 7, what does that equal to? Just 7. What is root 7 times negative 2 root 3? Negative 2 root what? 21. Okay, now what is 2 root 3 times root 7? Plus 2 root 21. And last, what is 2 root 3 times negative 2 root 3? Well, let's start the coefficients. 2 times negative 2, what does that give you? Negative 4. What's root 3 times root 3? Just 3. So what is this number 4? What would you call that? What happens with the middle terms here? They cancel out. So we're left with 7 minus 12, which equals negative 5. What is number 4? What is that binomial expression? What would you call that? It has a special name. It's part of the special rules. And they're not exactly congruent. They're not perfect. It's not a perfect square. A difference of squares, right? This is a difference of squares. You're close. Okay, difference of squares. Difference of squares. So there's a shortcut with difference of squares. Because with difference of squares, remember difference of squares, when you expand it, you're left with always a binomial usually, right? Like when we factored back in the day, x squared minus 25, what did that factor to? Do you remember? X squared, x plus 5 and x minus 5. And so what happens is when you expand that outer foil, the middle term always cancels out, right? So working backwards, if I have root a plus root b times root a minus root b, the middle term will just cancel each other out. So we really only have to worry about multiplying the two first and the two last. What is root a times root a? It's just a. What's root b times root b? It's just b, and the sign's going to be minus because it's actually positive root b times negative root b is minus b. Okay? And what we call those are conjugate pairs. Same but different sign in the middle. So a conjugate pair happens because what happened when we multiplied this difference of squares here? Did we have any radicals at the end? No. So conjugate pairs are beautiful in that they eliminate any square roots. So we're going to use them a lot in the future. Okay? So that's a term you need to know. I don't want you asking me what's a conjugate on your unit exam. Okay? So a conjugate pair basically forms a difference of squares with our radicals. They're conjugates of each other. Conjugates are same but different signs. Opposite signs in the middle. Okay, that's what the conjugates are. So for example, if I had, that's not what I want to write. If I had 2 plus root 3, what would be the conjugate to 2 plus root 3? 2 minus root 3. Good. Okay, and these are so important because when we want to rationalize our denominator, we're going to be using this because the difference of squares eliminates any square root. Okay. Question? Okay, so if I did expand this for fun, 2 times 2 would give me 4, and then negative root 3 times positive root 3 would be minus what? 3, or just 1. Because if we FOILed it out, the middle term, you would have had a 2 root 3 and a minus 2 root 3, and they just cancel each other out. Okay. Okay. Let's do 5. What do you have to do if you have a square? Could we just square each one? Classic error. Follows you. Happens in grade 10. Still happens in grade 11. I don't know why. When we have a square of a binomial, what do you have to do? Expand it. Write it out. How many times? Twice. It's multiplying by itself. And then what do? You can't just square both terms. There's a middle term in there, right? Then you're getting foiled by FOIL. There's that classic joke. Yes, you'll never escape it until you escape maybe high school. Okay. Possibly. Might show up again. Okay, so can you please FOIL this out? All by yourself. Use FOIL. Try it. You should have had 9 plus 15 root 2 plus 15 root 2 plus 25 times 2. Or we have 50 plus 9, which is 59, plus 30 root 2. Okay. What's root 3 times root 3? We can go through some of these really quick. Just 3. 5 root 6 times 2 root 6 would be 10 times what? 6, or 60. What could you do with number 3? What is that? These are conjugates. It's a difference of squares, yes. So root 6 times root 6 gives you 6. Root 2 times negative root 2 minus 2, which gives us 4. Okay. If you wanted to FOIL the whole thing out, you can, but that's going to take a while. And your middle term should cancel. So you don't need to. Is that a conjugate pair? Okay, try it on your own. So again, I'm eavesdropping on Abdullah. I'm going to say what you're saying. So really what we're doing is you're squaring each one with a minus sign in between. Right? Because root 3 times root 3 is the same thing as root 3 squared. Or 13, sorry, 13. So square root of 13 squared is 13. Minus 2 squared is 4. It's positive root 2 times negative root 2. And then 9. Easy? Fun? I really like this stuff. I'm hoping you do too. Okay, I think we're done, right? That's it for this lesson? Yes? Okay, good. Thank you for agreeing. You probably even... So what's the homework for today? Tomorrow's stuff is 3 pages, I guess. Okay. So your assignment is right here. Page 289 to 293. Okay, numbers 1, A, B, C, 2, A, B, 3, A, B. Please write this down right now so I can, or you have it on your first page, right? Your very first page. Oh, let's see.